All right, so this is going on page 92 when we're done. We are going to review solving right triangles. And this is a review. This is totally from geometry. Doesn't matter what campus you took it on or who your teacher was. This is part of geometry, no matter what level it was. So we are going to use this first we're going to use trig to find side lengths. And so what's our little acronym to use to remember what to do there? SOHCAHTOA, right? So SOHCAHTOA. And it does not do you any good at all if you don't spell it right. Yes? And we have already reviewed SOHCAHTOA, haven't we? Yes. Okay. So again, whether it's something that you write at the top of your paper every time you do it, or if it's just something you know in your head, at least write it down right now. But that's fine. We need to it says find the value of x, so we're using it to find side lengths. We can also use it to find angle measures. We'll look at that in just a minute. When I teach trig from scratch, like you've never seen it before, and introduce what it is and all that kind of stuff, I require everybody to label everything every single time until you get the hang of it, because the worst thing you can do is label the triangle wrong, because if you label it wrong, you're not going to set anything up right. But I think hopefully we're past that since this is a review. You don't necessarily have to label all three sides. Just remember you're labeling them opposite, adjacent, and hypotenuse. And here's the key, is that opposite and adjacent are the opposite and adjacent legs. The hypotenuse is technically adjacent to the angle also. Wouldn't you agree? Like this angle is made up of two sides, so both of those sides are adjacent to that angle. But the hypotenuse is the hypotenuse, and then this part would be the adjacent leg, and that's the key there. So you don't get it mixed, because that's where the labeling problem comes in. So when we look at number one, we should know that the side opposite the right angle is always the what? Hypotenuse. So that's my hypotenuse. Then this is my angle. This is the side across or opposite the angle, so this is the opposite side. So the adjacent side they didn't ask me for, and I don't know what it is, so I'm not using it. I'm only using opposite and hypotenuse, which means which trig ratio am I using? Sine. So this is going to be the sine, and you always take the sine, cosine, or tangent of an angle. So sine of 32 is equal to the opposite, which is 11, over the hypotenuse, which is x. Okay? So for this question and this question only, I'm going to do an extra step that you're not going to necessarily have to do, but I want you to see the math behind it. I want to get x by itself. Dividing by 11 does not do me any good, because that would leave me with 1 over x over there. So instead, I'm going to get x out of my denominator. So I'm going to multiply both sides by x. So I get x times the sine of 32 equals 11. But now I need to get x by itself. So what do I do to get x by itself? Divide by the sine of 32. So x is equal to 11 divided by the sine of 32. Okay. So there's my x value. Now we're not even touching the calculator yet. I should have said that for a minute. I'm sorry. That's my fault. We'll get to the calculator because you need the calculator for it, but just don't even push anything yet, because we're going to do number 2 before we go back and look at the calculator. All right, so let's look at number 2. This is my angle. So that's the side opposite the angle. So this is my opposite side. I'm sorry. You don't have to put OPP, but that's what I did. And then this is another leg. So this is the adjacent leg. So what uses opposite and adjacent? Tangent. It's not TOA, it is tangent. So the tangent of 75 is equal to the opposite, which is x, over the adjacent, which is 21. So I have to get x by itself. Since it's in the numerator, that's good, because now all I'll have to do is multiply both sides by 21. So x is equal to 21 times the tangent of 75. So here, in both of these questions, we have stopped at the exact answer. Do you have any concept of what either one of those values are? Probably not, and that's okay. But you need to get to this point on both of them before you touch the calculator. We're still not ready to touch the calculator yet. That is what the exact answer is. And again, makes you look like a crazy person to go to the Home Depot, right? I'm building this triangle, and I know what this side length is. I need a length of wood that is, this long, and so I need it to be 11 divided by the sine of 32. You look crazy. So this is your exact answer, but we also need our Home Depot answers. Okay. So if I have sine of 32 and sine of 39. Oh, I see what you're saying. Sine is not a number. Sine is an operation. I see what you're asking me now. It's because although these two things are being stuck together, we are not multiplying. It's an operation. That's kind of like if I have the square root of 7. I'm taking the square root of 7, which means I'm looking for a number that multiplied by itself would give me 7, right? So sine is it's not really an operation, but it's a ratio. The sine of 32 is always is a constant. The sine of 32 is always the exact same number because every single right triangle that has the opposite side and the hypotenuse that would be proportional, right? And the triangles don't have to be congruent, they just have to be proportional. Every single triangle, when y'all proved triangles are similar in geometry, you had something called angle, and that's an important one because it's still going to come up. So I have this right triangle right here, and this angle is 32 degrees, right? And this is a right angle. So these two triangles, not necessarily congruent, but they are similar, right? Which means they're proportional. So since they are proportional, if that's, and I know this one's smaller, but if that was 11 when we doubled the side lengths, that would make this 22, and then that would make this 2x. Does that make sense to you? So if I do the sine of 32 here, and I do opposite over hypotenuse, I'm going to get 22 over 2x. My 2's reduce out, and I get 11 over x. So the sine of 32 is the ratio of those side lengths. And it is the same number every single time. And that's why we get to use it for something like this. Like, I don't know what the, because I'm looking for the side length, obviously, but the proportion is the same. So even if I was to type this in once I get the actual number, since any number I would have put here, like if I double it or triple it, it's going to reduce to this every single time. That ratio is the same. And that's the whole idea with trig. Does that make sense? That's a good question. And it's hard to really fully explain that when you very first learn it because it just all seems so weird anyway. But it is good that you're not just okay with just, randomly doing things. It's that, you're actually, why does this even work? It's because of this whole ratio thing. Okay, does that help? We good? All right, so I wanted to back up one thing here. So when I did this and I said we're going to do an extra step and then I forgot to clarify that. So I want you to see this is where we started, this is where we ended. All that really happened were these two things, since this was in the denominator, you see how they just switched places? Okay, so that's not magic. But mathematically, that will happen every time. Because if every time you have a variable in the denominator, you multiply both sides by the variable, then you divide by the other thing, you're going to end up just switching those. So it's fine to skip this step. But I never skip it the first time we talk about it because I don't want you to think it's some math magic that you can just willy-nilly switch anything you want, okay? Because that doesn't work that way. But it's fine. It's just it's just a shortcut. Like, what's going to happen. We don't need to do that. If you're unsure or you were confused about what got switched, you can do the math. There's nothing wrong with it, but you can also skip the step. All right, so because you don't have any clue, if I said, what is the sine of 30? That's something you should know, right? What is the sine of 30? What's the sine of 30? 1 over 2. And it's the same every single time, right? And that's one you know. Sine of 30, 1/2. Do you know what the sine of 32 is? No, you don't. Okay, and you shouldn't have to. The calculator does it. The calculator isn't actually, I said it's an operation. It's not an operation. It's not calculating it. Well, you can calculate it, but you don't want to. But it's kind of pulling it off a thing. When I very first started teaching, and there were calculators. I'm not that old, but not every classroom had a set of calculators because you weren't allowed to use them on the state tests. So they weren't. So the geometry classes didn't have calculators because the test that the sophomores took, you couldn't use it on there at that time. So we had to use the trig tables. And so the older textbooks have trig tables. And that's what engineers would use and they would use in businesses. And so the tables, obviously for the sine of 30, it would say 0.5. But for every other ones that weren't exact, it would have it to 4 decimal places. And that's what they would use to calculate, to be able to do it by hand or whatever. But now if you just hit sine of 32, the calculator gives you a number because it's giving you that ratio. Okay. But even though I know you don't have a concept of what this number is, you kind of do. Because before we type anything in the calculator, if you look at this picture, there is something you can tell me about x. What can you tell me? No, because you don't have that to do that. But I don't mean tell me the number. I don't expect you to give me the number. But there's something you can tell me about the answer. What do you know has to be true about x? It's going to be positive. It's going to be biggest. So it has to be more than 11. So positive is important because sometimes you get negative numbers and that just means you're wrong. It has to be greater than 11 because it's the hypotenuse and it's the longest side, right? So one more thing that I don't expect you to overanalyze every question like forever, but this is 32. That's really close to 30. If this was 30, then what would the length of the hypotenuse be? Now, sine of 30 is 1/2 because opposite over hypotenuse is 1/2. So if I was going to get that, and if this was a special right triangle, this is s squared of 3, this would be what? What would give me 1/2? 11 over what would give me 1/2? 11 over 22, right? So if this is s, this is 2s. So if this was 30, this would be 22. Do we agree with that? So what we know then is it's positive, it's bigger than 11, and it should be close to 22. Like if a reasonable answer, even though it's positive and greater than 11, 5,000 is not a reasonable answer, right? Even 30, honestly, is not a reasonable answer because I know it should be kind of close to 22. Do I expect you to spend 5 minutes overanalyzing every question every time? No. But what I do expect is that if you get some random crazy answer, most of the time you can catch yourself. And the more you think about those things as you go through these problems, the more likely you are to catch it. And it doesn't take you nearly as long to actually think through it than it does for me to talk you through it like this. All right, so with all that said, now let's look at number 2. So tell me something about x over here. Okay, it's not the hypotenuse. The second biggest, I don't even know all 3 sides. So is it going to be bigger than 21 or smaller than 21? Bigger. Why? Because it looks like it? No, you can't go by the way it looks like ever. Well, and I don't want you to try and come up with the number. Like that's not like a necessary part of that. You don't have to give me exactly that stuff. But it's not 30, 60, 90. So no, I can't do the special right triangle thing. It is going to be greater than 21, but tell me how I know that, not just because it's drawn like that. Right, but the fact that x is bigger than 21 right here has nothing to do with trig. Nothing. The angle. It does have to do with the angle. Remember the longest side is across from the biggest angle? If this is 75, what's this angle? 15, right? So 15 is a lot smaller than 75. So this angle right here, since it's smaller, this side is shorter. So not only is x going to be bigger than 21, it's not going to be like 22 or 23. It's going to be a lot bigger because 75 it's opened up a whole lot more. So this side over here is going to be a lot bigger than this one. Does that make sense to you? So those are things that, can help you with reasonable 7 answer. And again, you'll recognize them more if you just at least think about it. All right, so let's go ahead and type these in. Go ahead and type in both of these answers. Or actually, just type in number 1 and stop for a second, and then we want to talk about number 2. So we're going to do 11 divided by the sine of 32. And I get x equals, what'd you get? Good, 7, 5, 8. Good job. Okay, do we all agree with that? Yes? Okay, so now once we've all gotten that one, go ahead and type in number 2. Now, did you expect to get an answer like that? No. You expected to get a crazy decimal, right? Is 75 one of your special angles? No, it's not. But 75, isn't it 60 plus 15? 60 is a special angle, and 15 is half of the 30. So remember how it's come up a few times. Half of pi 6 is pi 12ths, right? So if I add pi 12ths to the 60, so basically I don't expect you necessarily to come up with it, but that's why it happened. You can put more angles on that unit circle than we have on there, or at least you could figure them out if you had to. But even though we like, exact answers a lot of times, I want a Home Depot answer. So how do I get it? The SD button, yes. So I get that x is equal to 78.373. All right, we're going to do 3 together, and then I'll have you do 4. All right, so number 3. This is my angle, right? What do I label x as? Adjacent, and 30 is hypotenuse. So adjacent and hypotenuse, I'm using what? Cosine. So the cosine of the angle, the cosine of 23, is equal to, bless you, the adjacent over the hypotenuse. What's my next step? Multiply by 30. So x is equal to 30 times the cosine of 23. So once you have x isolated, then you can type that in. And that's what I got. See if you, and if you're not agreeing with me for some reason, let me know. If there's an issue typing something in the calculator, please always let me know. The nearest thousandth. It says it here, and if it doesn't say, then you do to the 3 decimal places for sure. Okay, any questions? All right, y'all do number 4. Did you have a question for him, or were y'all just discussing what was? Okay, did y'all figure it out though? Okay, just want to make sure. Exactly. Okay. Okay, you're good? No. Okay, so once you got done, what do you think about that answer? Like, what doesn't seem right? Okay, and it's not, because here's what happened. This is in the denominator. These two things switch places. You don't get to take the reciprocal of 2. Good. Okay. You have it marked opposite and adjacent, and that's correct. Tangent is opposite over adjacent. You put adjacent over opposite. You haven't even written anything down. I know, that drives me crazy too. Yeah, check too, you were good. Let me back this up. All right, so here's my opposite, adjacent, using tangent. I'm just going to come back and see where you were. And then this is opposite over adjacent. You have it labeled right. Tangent is opposite over adjacent. You have adjacent over opposite. You have it labeled correctly. You did not put it in here correctly. Okay. So guys, since x is in the denominator, these two things just switch places. So you get x equals 15 over the tangent of 41. And then once you type that in, you get x equals 17.256. So let's, I want to talk real quick about reasonableness of this answer, which I should have asked you before I let you type it in. But I know you already know what the answer is, but tell me something you would have known about x before you even typed it in. It is the adjacent. It has to be bigger than 15. Why? Because the angle is bigger. Because if this is 41, this would be what? 49? Okay, it'd be 49. Okay, so, and then not only would it have to be bigger, but both of this is close to 45, right? And if they were both 45, wouldn't these be congruent? So not only should it be bigger, it's not going to be a lot bigger because the angles are kind of close in size. Does that make sense? So it should be, somewhere in the ballpark of 15, and I would say 17 is, in the ballpark. So that way if you get some random crazy decimal, that's when you go, this just can't be right. Or sometimes you get a crazy random number that you don't like, and you realize, well, it actually is reasonable. That's usually when it's really important because it pushes you out of your comfort zone and you just assume it wrong. All right, so let's look at this. It says, given the trigonometric value of an angle, use the corresponding inverse trigonometric function to find the measure of the angle. Okay, so remember this. This sine of theta equals x. These two things are not being multiplied. This is not multiplication. That's like saying if I had the square root of x equals 5, and I'm trying to get x by itself, that I would divide both sides by the square root sign. That doesn't make any sense at all, does it? And not a single one of you would do that. But just because they're stuck together doesn't mean it's being multiplied. You with me on that? Maybe I would have. I don't know. But you wouldn't have done that. So I'm not going to divide by sign, because sign by itself, like if just sign, has absolutely no value. That right there has nothing. Just like this has no value, right? It's telling me something about it. So you have to do the inverse. The inverse of the square root is squaring it. So that's why we would square both sides. So the inverse of sine is the inverse sine. Okay? It looks like this. So if sine of theta equals x, and I need theta, I need to move that away, then theta is going to equal to sine inverse, which looks like sine to the negative 1 power, but it's not, okay, of x. So just like you always take the sine, cosine, or tangent of an angle, you always take the inverse of a ratio of side lengths, okay? So then cosine of theta equals x means that theta is equal to the cosine inverse of x, and then theta would equal the tangent inverse, or inverse tangent. You can see it as tangent inverse, inverse tangent, or arctangent. They all mean the same thing, just different ways to express it. Okay, we all good with that? So let's look at number 7. It says, find the measure of theta, round to the nearest thousandth of a degree. So we start the same way. This time, this is the angle I'm using. I don't know what the measure it is, but that's the one I need. So this right here is the adjacent leg, and then this is my hypotenuse. So what uses adjacent and hypotenuse? Okay, come back up here. Adjacent and hypotenuse. Cosine. Okay, none of the above. Cosine. So I'm going to take the cosine. You always take the sine, cosine, or tangent of an angle. So the cosine of theta is equal to the adjacent, which is 18, over the hypotenuse, which is 23. Now, that doesn't reduce, but even if it did, I don't care, because I'm not done. This isn't my final answer. I'm going to actually find theta, so don't bother trying to reduce it there, because that's an extra step you don't need and one you might mess up. But if cosine of theta equals 18 over 23, then theta is equal to the cosine inverse of 18 over 23. So on this calculator and on all of the calculators I've ever seen, I can't say on all calculators ever, the inverse functions are right above the functions themselves. So, let me calculate over here. To type it in, it would be, so I do shift cosine, and then I have 18 divided by 23. And it's fine to put it in as, oh gosh, you can't see that, as divided by like that instead of like a fraction. I thought I finally fixed it where you could see it. I just can't. But that's fine. You get that, and you get this decimal, right? So there you go. That's where you can see it. I'm going to figure that out one day. What you get in the calculator is, oh, I just cleared it off. I have it written down up here. I get 38.49993, ... right? So when you round, we are rounding to 3 decimal places. So when you round to that 3rd decimal place, you look at the 4th one. This 9 rounds this 9 to a 10, which rounds this 9 to a 10, which rounds this 4 to a 5. Does that 5 round the 8 to a 9? And then the 9 round the 3 to a 4? No, okay? And I have kids that will swear to me that's what their teacher taught them. I'm like, really, honey, that is not what your teacher said. Might have been what you interpreted, but no. I call that domino rounding. Let's just round them all. No, I mean, it does happen a couple times here, but that's because of the nature of that. So my answer is theta equals 38.500 degrees. And those zeros there mean something. They mean that I had to round and there is more stuff out there. Does that make sense to you? If you do something and you get exactly 38.5 and it says round to the nearest thousandth of a degree, your answer is 38.5 because that's what you got. So I know that they don't add a value, but it tells you something about the number. Okay, we all good with that? That's the answer because that's my angle measure. Okay. All right. So let's do number 8 together. Here's my angle. What do I label 5 as? Opposite. What do I label 21 as? Hypotenuse. Yeah. It's the hypotenuse. Cross from the right. And and honestly, on some of the weird shaped triangles, it helps to actually draw the arrow, like that's my hypotenuse across from the right angle. It's easy to label things wrong. All right, opposite and hypotenuse, which trig function is that? Sine. So the sine of theta is equal to the opposite, which is 5, over the hypotenuse, which is 21. So theta is equal to the sine inverse of 5 over 21. I tried that. I did that. And then, well, then I moved this. And I moved this yesterday when I was making another video because I don't like it like this because I don't like to put my back to y'all, but I don't know. I probably just need to walk around there every time. I need to see if I can find some way to project that, but I doubt I can. All right, so what did we get? Y'all agree with that? Degrees, very good, because those X's we had up there, we didn't have units on them because they didn't give us any, but here we know it's degrees, and that's very good. All right, any questions? We good? All right, does this sound familiar? Please say yes. Okay. All right, so I feel like if you can do finding the side links, you can find the angle measures. My board will catch up in just a second. So I don't know. Do we need to do any more finding the angles real quick? Because there's going to be another one on something we do down at the bottom. You think you're good? And because it's going to come up again. And if not, and we have time at the end, I'll do another one. Let me wait for my board to. All right, so we're going to jump to number 13. So on the last two types of things we did, it said either find X or find a side length or find the angle. This is solving the triangle. When it tells you to solve the triangle, you have to find everything that you aren't already given. So I'm given 2 angles and a side. I need to find 2 sides and the leftover angle. So when I go to do that, it doesn't really matter which side I start with, but this is my angle. So I'm going to need to label all 3 sides. This is my angle. Across from the angle is my opposite side. The other leg is the adjacent side, and then I have the hypotenuse. Okay, those are the things I'm going to need to find. I also need to find the measure of angle B. Is that pretty easy to find? How can I find the measure of angle B? 90 minus 72. Now, I could add 90 and 72 and subtract from 180. That works too, but you don't need to because these two have to be 90. So the measure of angle B is equal to 180 minus 72. Not 180, dang it. I just said that and I had 180 on the brain. I was also hearing what you were saying because you were doing the adding because that's how I made y'all do it, right? I heard something plus something. I don't know. What were you saying? You said somebody was adding something. You're saying it out loud. Maybe I'm hearing things. Never mind. Okay. And that's okay because it's X plus 72 equals 90. I mean, that's because that's technically using this up. But, I'll take credit. I thought I heard it over here. Maybe I'm hearing things. Anyway, now, is that something we should be able to subtract in our heads? You can't subtract those 2 numbers? Oh my goodness. Yes, but you should. But if you were allowed to use a calculator, which you are in the trig step, then use it. Don't miss stuff like that. Because when I work through this stuff, I work through it a couple of times, and then if I have a key to where I took a problem from, sometimes I make them up so there is no key, then I'll check myself. And anytime I don't agree with the key, then I assume I'm the wrong one. But on this particular problem right here on 14, we're not going to do 14, but finding the angle, she had 66. And said I had 56. And I thought, oh, dang, but I was like, oh, no, it's 66. But she just subtracted wrong, which this is the type of thing y'all subtract wrong on all the time because it's easy. You don't think about it very long, so you just write something down, you move on. If you have that calculator, then check yourself, even on easy stuff. I appreciate the fact that you're not all grabbing it to do that. You know, give yourself an answer, then check it. That's better than not even thinking about the number. But my whole point for all that was just, yeah, don't miss something simple just because you didn't use the tool that was in front of you. All right, so then we're going to find, we'll start with the hypotenuse here. So I'm going to say that I'm using hypotenuse, and I'm going to have to use adjacent because that's the side they gave me. What uses adjacent and hypotenuse? Cosine. So the cosine of 72 is equal to the adjacent, which is 15, over the hypotenuse, which is the length of AB. Right? So the length of AB is in the denominator. I get to switch places with the cosine. So the length of AB is equal to 15 over the cosine of 72. And then at that point, Go ahead and type that in. Oh, I sure did. Thank you. Yes, I forgot my degree sign. That's important. I know. All right, so you should get 48.541. Actually, I might have counted it wrong. 18 what? All right. Now, once I found AB, I got a couple of options. Like if sine is just your favorite, you just have to use sine. Well, you can use the hypotenuse you just found to find the opposite, but you'd have to store that number because remember, we do not type those numbers back in. But it's really safer to use what they give you, so that's what we're going to do here. And still using the adjacent, but this time opposite. What function uses that? Tangent. So the tangent of 72 is equal to the opposite, which is the length of BC, over the adjacent, which is 15. Well, 15 is in the denominator, so BC is equal to 15 times the tangent of 72. And then you can type all that in. That's what you should get. Oh, no, that's wrong. Sorry. I have short-term memory issues from the time I look at my paper till when I walk over to the board. 165. No, I had the right numbers. I just couldn't. No. 165, not 615. Okay, everybody okay with that? We all good? All right. Let's look at 15. So on 15, I have to find a side length, and I have to find two angles. So let's start by finding the angles. Which angle you want to find first? L? Okay, so I heard L. That's what we're going to go with. We're going to find out because it doesn't matter. So this is my angle I'm using. This is opposite. This is adjacent. This is hypotenuse. In order to find that angle, what do I have to use? Opposite and hypotenuse, because that's where my information is, right? So go ahead and find that angle on your own. Because that's one I didn't have you do on your own. Remember, you set it up the exact same way you did the rest of them. You figure out which trig function you're using, and you do the sine, cosine, or tangent of the angle, set up the ratio. Are you stuck? Okay, so are you going to use sine, cosine, or tangent? Okay, so so once you make that decision, that's great. So now you put the sine of the angle. We can call it L. So, oh, is that what you were stuck on? Okay, I'm sorry. Okay, so the sine of L, or you could have called it theta, or you could have called it X. Oh, you got to call it something. Okay, yes. So sine of L is equal to the opposite, which is 7.6 over the hypotenuse, which is 8. Okay, I didn't realize that. That's okay. X is a variable. You're not really going to use it for angles anymore, but that's fine as long as in the end you don't tell me X equals whatever. When things you really use X for when you don't have things labeled already, but because I have something to use there and it's L. It's actually the measure of angle. All right, so next thing I have to do is take the inverse, right? So now the measure of angle L is equal to the sine inverse of 7.6 over 8. So type that number in and then don't hit clear because I want to talk about what happens now. Sine inverse of 7.6 divided by 8. So you should get 71.805. And always make sure you're writing them in the correct blanks when you have that stuff going on. Now, in order to find K, I could do trig again. Would you agree with that? But what could I also do? Subtract. So you got two options. The one option I usually do is just, since I know I need to subtract it from 90, I'll just do minus 90. It gives me a negative number, but I know it's not supposed to be negative. Does that make sense? Because I'm lazy and it's just less keystrokes. But yes. And so here's a couple of things. You could store it, but you don't even have to store it. If I have this in my calculator right now, and I just do 90 minus answer down there by the equal sign. Hit answer, it'll subtract the last answer you had and give you what you have. But remember, you do not type the decimals back in, okay? Even though I know sometimes you might get the same answer rounding wise, but you don't always, so it's not a good habit to do that. Sometimes it does and sometimes it doesn't. No, if you round it correctly here, they will. So it's 90 minus the measure of angle L. Yeah, that's equal to the measure of angle K. And so that gives me, what was it? Yeah, 18.19. If you round them too early, they may not add up, but if you round them this way, they will. All right, so then I have to find the length of JL. I can use trig for that, right? But if I was going to, I'd have to store one of these two angles. Because if I just take the sine, cosine, and change it on one of these angles and find my side length, I will be off on my rounding for sure. So I could store the angle and I could use the stored number. But what's another option? How do you find the missing side of a right triangle? Pythagorean theorem, right? You've been doing that forever. So just because we're doing trig doesn't mean we couldn't do Pythagorean theorem. We could have done Pythagorean theorem on this one. Once I found the hypotenuse, I could have used the stored number in 15 to find this one. I could have done it there too. I think trig makes it easier, but here, yeah, I could do trig, but Pythagorean theorem's better. So I know that 7.6 squared plus the length of JL squared is equal to 8 squared. So I'm not going to actually square anything out yet. I'm just going to subtract 7.6 squared from both sides. So this gives me 8 squared minus 7.6 squared. That would leave me with JL squared, but I really want JL, right? So I would take the square root of both sides. So JL is really the square root of all that mess right there. You agree with that? And since the calculator is doing it for me, let the calculator do all of that. Hit the square root sign, type all that in using the squared button, and you don't have to come up with anything. And I see sometimes when people are doing squared, they use the caret top with the 2. That's not wrong, but most calculators that have anything more than add, subtract, multiply, and divide have a squared key. And so if we were using the 83s that y'all used to use in class, we would have to have parentheses here because it doesn't extend the square root. So just make sure you know what kind of calculator you're using. So even like on your phones and stuff, you could do this, but you may have to use parentheses. So just be careful. Make sure you know the device you're using and how to do it. So once you do that, it does it all in one step. It gives me the exact answer, though. I don't want that, right? So I hit my SD key to get my decimal. Okay? So we get the length of JL is 2.498. Yeah. Uh-huh. The square root would cancel out what square? The square root would cancel these out? Not in any universe I've ever lived in. No, no. Big fat no. If it did, I want you to think about that. If that did happen, so when we say a squared plus b squared equals c squared, and I took the square root of both sides, then that would mean that a plus b equals c. If that's true, why the heck would we complicate it that way? Not the same thing. Not even close. Okay. Anything else? We good? Y'all can do this, right? To review. Yes? Okay, good deal. All right, so go ahead and glue or tape those in. And I will hand out your assignment. It is one-sided.